Assalamu alaikum. How are you, my dear students? We still in lesson 9.3, exponential growth and decay. This is the third part of the lesson, exponential decay. That will be example 3. The exponential decay occurs when a quantity decreases by the same rate, or in English, decay means fainting or dying, okay, gradually. Here we are representing the decay by a function that has a ratio less than 1. Okay, so when I multiply a quantity by a factor less than 1, what will happen to it? It will be reduced, it will be lesser, right? This is the function of the exponential decay. It has r less than 1. Look at that. Here, the equation y equal a multiplied by 1 minus r all power t. So here, what make it different from the growth is that minus. When I make 1 minus r, so it will be less than 1. So the answer will be less than a, right? So a is the original amount, r is the rate of decay, or if the rate of decreasing, it will be as decimal, and t representing the time, right? He say here, the population of town is decreasing at a rate of 3% per year. In 2000, there were 1,700 people. Write an exponential decay function to model this situation. Then find the population in 2012. Alright, remember that the function will be y equal a multiplied by 1 minus r. 1 minus r power t. So a is what? Is 1,700. R is what? Is 3%. That means 0.03. And t is what? T is 12. From where? Because he said in the year 2000 it was 1,700. What will be in the year 2012? So there is 12 years between the year 2000 and 2012. Now substitute for a and r. Y equal 1,700 multiplied by 1 minus 0.03 all power t. So to simplify it, it will be 1,700 multiplied by 0.97 all power t. And then that was the function. Now substitute for t with 12 to find the final quantity. Y equal 1,700 multiplied by 0.97 all power 12. Okay, calculate it. Equals 1179.53. You have to notice that the final answer less than the original quantity. That's because I multiplied it by a fraction. What is the fraction? The 0.97 is a fraction in a form of decimal. Okay, so when I multiply by a decimal or a fraction, the quantity will be reduced. So if I multiply the 1,700 by 0.97, 12 times. This will be the answer. So if I multiplied it by 0.97, 0.97, again 0.97, 12 times multiplication of 0.97, that will be the answer, right? In a direct and very important application about the exponential decay, there is the half-life. The half-life is a chemistry application or a physical application about the exponential decay. The half-life happens or concerning of a substance in the time it takes 1/2 of the substance to decay into another substance. If there is substance and this substance is not stable, so it makes radiation, and this radiation make the substance reduce its mass, reduce its quantum, reduce its material by radiation. So what will be left if the radiation cancel its half of the mass? طيب, all the materials that has radiation lose its half of its mass, but it different about in how many time or what at the time it will lose its half of mass. It depends on that material, and I have one form of equations: A equal P, the principal, multiplied by 0.5 all power T. Here the R is one quantity, always be 0.5, always be 0.5. Let's take a question. Stalin 218 has a half-life of 2 seconds. Find the amount left from a 500-gram sample of a Stalin 218 after 10 seconds. Okay, what is A? A is 500, or we can say it's P, principal, means, right? What is R? 0.5. Okay, we say it's constant here, we don't change it in the half-life examples. But what is T? This is the point. This is the different thing here in this example from other examples. That T is not given directly. The T here, I can notice it from two statements. Look at it. He say here the half-life of 2 seconds. So it lose its half of its mass in 2 seconds. What will be left if it lose its half? How many times? 5 times. Okay, why we say that? Because its period takes 2 seconds. In how many period? It will take 10 seconds. That means it had 5 periods. It lost its half mass 5 times, because 10 divided by 2. Alright, so now y equal 500 multiplied by 0.5 all power 5. And we said that 0.5 is constant. I bring it from the rule. It is not from the question. When the question say half-life, I put 0.5 power T, and the T is how many periods? Okay, now what is the answer? 15.625 grams. Right? Let's take another. Acetylene 218 has a half-life of 2 seconds. Find the amount left from a 500 gram sample of acetylene 218 after 1 minute. Now, after 1 minute, so the T here is different from the other example. T equals 1 minute is 60 over 2, that means 30. That means 30 periods. A is 500. Now y equal 500 multiplied by 0.5 all power 30. So you just write 30 instead of 5 in the other question that give you 0.000000465. The 5 will be 7. The 5 will be 6 grams. Alright, this all about exponential decay and the half-life. Okay, see you later.